All right, we're going to do just one more example. That's all we're doing today that we didn't hit yesterday. So let's just do the one example. That would be example 2. And it's going to say, well, this one just asks you to find the minimum. All right, they could ask you to find both. It's really not that hard. Once you do all the work, you do the graph, you plug everything in. The easiest part is finding the maximum and minimum. Just find the biggest number, the smallest number. But they just say minimize the objective function. Not really sure why they say that, but this is what we're going to do. They give you a function. Yes. Man, I thought you were going to have a good math question. Ask me a good math question first. That's what I should make you guys do. Can you think of a good math question? How bad do you have to go to the bathroom? Just go. I'm just messing with you. Well, ready to pass. You can't just walk out. I thought that was a given. All right, this time you have 4. Did you have 4 on the homework? Did any of those have 4? No. 3 was the most? Okay. Well, this one you're doing 4. Let me see. Yep, 3, 3, 3, 3, 3. All of them just have 3. This one has 4, so that'll be fun. All right, so first thing we're going to do is we're going to graph them, but before we graph them, you're going to have to change a couple things. Not much. That's already ready to graph. That's ready to graph. What about this one? Just one little easy step. Subtract an x from both sides. So that's negative x plus 4, so we can graph that. And basically the same idea here. Just get y by itself, subtract a 3x from both sides. There you go. All right, so we're going to graph these things. So let me grab a graph. Right here. Make it a little bigger so we can work with it here. That should be good enough. Let's put that right there. There we go. Fits perfect. All right, now we're going to graph everything. I'll make them different colors. All right, x is greater than or equal to 0. So if I said x was equal to 0, how would I graph x is equal to 0? What kind of a line would that be? They're all straight lines. Don't say straight. It's a vertical line. I heard somebody say vertical. Good. So it's going to be a vertical line. Now these are all greater than or equal to, so that means every line that we're drawing here are solid lines. So that's my first one. Everybody see that? Because when it says x is equal to something, that means it's a vertical line and it goes through the x-axis of whatever it's equal to. So it goes through 0 on the x-axis. So it's a vertical line right here. Right? It's or equal to, so it is solid. We're going to save the shading to the very end. All right? But let's just think of where the shading would be. So far, the shading would be where? If it's greater than or equal to 0. To the right. It'd be everything over here on the right. Okay, so far. But we got to do the rest of them. What about this one? Y. What if I just said y equals 2? What kind of a line would that be? Be a horizontal line and would go through the y-axis where? At 2. So let's do that. So there's 2. And it would look like that. Now, it also says y is greater than or equal. So far we got everything to the right of the red one and above the green one. So it's basically, so far it's everything in here. Everybody see that? Well, we got 2 more to do, right? So we're going to restrict it just a little bit more. So let's graph this one. Let's go blue. Okay, let's graph this one. The y-intercept is 4. 1, 2, 3, 4. Slope is -1, -1, -1. It's probably good right there. So that's going to go like this, and it's going to go down like that. That looks pretty good. All right, so where is it now? So it's to the right of the red one, it's above the green one, and it's what? Greater than the blue one, so it's above here. So far, this is what we're shading. Agreed? But we got one more restriction. We got this one right here. So let's do that in a different color. 6. I think 6 is all I got. 1, 2, 3, 4. Nope, I got more. 1, 2, 3, 4. Oh, my graphs go to 8 on this. All right, so 6, and the slope is -3. 1, 2, 3, 1. That's good. 1, 2, 3, 1. Let's do a few more. 1, 2, 3, 1. One more. 1, 2, 3. Okay. Let's graph that. So that would go from here to here. And we'll just take that all the way down. All right, I think that's pretty close. Does that look good? Yeah. All right, so now I'm going to go purple. That'll be my combination of everything. So where are we shading? Well, it's everything to the right of the red, above the green, above the blue, the yellow, and above the blue. So where is it? It's all this. And then, everybody got that? All right, so that's our shading. So that's what they want you to do. And now they want you to find the minimum. So how in the world do I find the minimum? Well, first of all, I got to find the vertices, correct? So let's find all the vertices to where this shading is. So where's the first vertex? I would say right there, wouldn't you? Then it goes down to here. Actually, yeah. It goes to here, then it comes down the blue. Right, so that would be another one. And then where's another one? Hits that green and it goes this way. That's all the vertices, isn't it? Even though we got 4 lines, how many vertices do we have? We just have 3 of them. All right, so there's one, there's another, there's another. So let's write down what those vertices actually are. So this first one that I circled right here, where is that? That's 0 what? 6. So 0, 6 is one of our vertices. What's this one right here? 1, 1, 2, 3. So 1, 3. And what's this one right here? 2, 2. Everybody good? All right. So that's good. I mean, the shading helps us find which vertices that we are using. All right, we're just using everything in that purple region, so those are the vertices to that purple region. So that's why we shade, so we can find which vertices we're going to use. Now, let me take that down a little bit. Here's our function. Now we're finally going to use this function right here. How do we use that function? Well, I use those 3 vertices, and I take the x and the y, and I stick it into that function, and I see what I get. All right, so let's do that. So I'm putting it into 5x plus 2y. So put a 0 in for x. That's 0 plus 2y, 2y, and that gives you 12. All right? So the number that's associated with 0, 6, according to this function, is 12. Let's put in a 1, 3. So 5 times 1 is 5, plus 2 times 3 is 6. Can we do that in our head? 6 plus 5 is 11. Let's do one more. 2, 2. So 5 times 2, you could just do that in your head, but I'm going to write it down. 5 times 2 plus 2 times 2. That's 10 plus 4, which is 14. Now, it only asks for the minimum, to minimize it. That's what they say. They say minimize that function, which means just find out the minimum value. So what's the smallest number out of those 3? Well, 11 is, And where is that located? What is the minimum? What is the point that gives you the minimum value? It's 1, 3. So the minimum is 1, 3. So that is our answer. Now, I don't know if it's a good thing or not, but I think I'm okay with this. It'll save us a day since we missed a day. There is one more example on this lesson, and it's a word problem, big old long word problem. And it's kind of a fascinating word problem, but it shows you, because you're probably looking at this and you're like, what does this mean? Why is this helpful? Well, that problem, that example 3, shows you where it's helpful, all right? Again, I just didn't want to go through it because it does take a long time, and I don't think, I'll make an adjustment if I did, but I don't think I put it on a quiz or a test, all right? The big word problem thing. So I'm just not going to go through it. But if you want to look in the book and look through it, it's basically this. It's basically that example. This store wants to sell a couple different items, all right? Like snowboards, I think it was. They got one type of snowboard, they got another snowboard. One's kind of cheap, one's kind of expensive, and they got to figure out how many of each snowboard should they sell to maximize the profit, okay? Because if you're a store, there's a lot of math that goes on with stores on how much they want to order, how much they want to keep in stock, and that kind of thing. Because you could lose a lot of money if you get all this inventory and you're not going to sell it, you're going to lose a ton of money. So you've got to be careful about how much you bring in, how much you sell it for, right? What the cost of it is. There's a lot of math. And this stuff that we're doing right here can be very, very helpful with that, right? So there's certain reasons why you'd have these equations right here. They kind of show it to you in that example 3. But this is what you would do. You would take those equations, and these equations mean something. It means like how much of this snowboard are you going to sell it for? You're going to sell this one for like $3 each. You're going to sell this one for like $1 each. Or of course, if they're snowboards, it'd be different. It'd be $300 and $100 or whatever. Okay, and you want to sell like more than 6 of them, or whatever the case is. And then you plot it and you see it, and you're like, okay, what's my maximum profit? Well, my maximum profit would be this. So I'd sell 2 of these snowboards and 2 of the other snowboards, and that would give me my maximum profit, right? If I only sell 1 of this snowboard and only 3 of these, then I'm only going to profit this much. Does that make sense? So this is used in the real world situations. And if you want to take a look at example 3 and kind of see what they're doing, feel free to do that. But I just made a game time decision and decided not to do that. It is kind of fun, but it does take a long time. I think we took at least the whole period just to do that one example, all right? Because it's a little bit involved. But it's nice to know how to do this, because you could be in situations where this could be helpful, especially in the business world. We think of math all the time as just like engineering, maybe computer science and stuff like that. But in the business world, they use, some pretty good math things. They use calculus. If you're a business major, a lot of business majors make you take a first-year business calculus class because you use a lot of those principles in the real world. Now, the way it is now, people have already programmed all that stuff into computer programs, right? So if you want to find out how much of this you should sell, how many of this you should sell to make a certain profit, all you got to do is just put the numbers into a program that they have, and it tells you all that stuff. But how do they get those numbers? They get those numbers by doing this kind of math, all right? So you still need people to program the stuff. You're like, well, we just got computer programs for that. Well, there's people behind the scenes actually knowing this math and actually programming those programs, right, so that you can use them. Does that make sense? All right, so there is a need for this kind of thing. Just thought I'd throw that out there, because I know what you're thinking. I mean, you're looking at this stuff and like, what did I just find? Who cares if I find the minimum? Who cares if I find the maximum? But when you're selling stuff and you have a business, you absolutely care how many of these you sell compared to how many of those you sold, right? Whatever the thing is. And that's kind of what goes on behind the scenes. All right? Does that make any sense? Yeah. Okay. Well, we'll stop there with this example, and then if you have any questions on that homework you had last night, maybe we'll do one or two of those before we get out of here. Everybody good with that? All right, I'll close this one down.